Okay, so in this video tutorial, we're going to be taking a look at how to assemble this very basic assembly for the Automata using the PLTW box kit. All right, so in the previous video tutorial, we were taking a look how to create the square dowel, which we're going to use as our axle, and how to create the small round dowels, which we're going to use as our follow rods, and how to create actual shaft collars to keep our axle centered in our very basic Automata assembly. So now we're at the point where we can begin assembling all these parts to create our Automata. So in order to do this, I'm still looking at my assembly for my basic Automata, and then what we're going to do is we're going to come out here and we're going to go ahead and place in some of the parts that we're going to need. So the first thing we're going to do is go out there and we're going to call on the axial IPT that we created earlier. I'm going to go ahead and just bring that in. All right, and I guess at the same time, let's just go ahead and place in, we're going to need 2 of those follow rods. So let's go ahead and just drop those in. I think those were at 6 inches or something like that. All right, so they might be a little bit tall, but who cares? Let's just make the thing work, right? All right, so to get a square to go into a round hole, all right, there's a couple things we're going to have to do. All right, so we actually need to talk to the square dowel because we're going to give ourselves a just a little helpful, I guess, tool or helpful feature is going to allow us to get these to line up. All right, so I'm going to actually just double click on that square dowel from earlier. I'm talking to that IPT, and here's what we're going to do. We're going to start a 2D sketch, okay, on this face here. All right, I have a point, okay, that is currently there. All right, and we can use that point, to create something called a work axis. All right, so if the point is not there, what you can do is actually come up here and actually draw a point, all right, and place it there. But I can see that my origin point is there, so we're basically good to go. So now what we're going to do is we're going to finish that sketch, okay, and now I'm going to come up here and look for an axis. Okay, so I'm going to go ahead and pick on axis. I'm going to go ahead and pick on this point. All right, and then all I have to do to complete this is just now come over here and pick on this face. I know I have a white background, it's hard to see it, but there is an axis that is going right down through the center of that, okay, and perpendicular with that face. All right, that's a very helpful thing to have for this next part. So now what I'm going to do is go ahead and return back to my assembly. Okay, and now what I'm going to do is I'm going to come in here and go to constrain, and I'm going to use my mate type of constraint, and I'm going to pick on that work axis I just created previously. And if I come to the inside of this hole, you're going to see that this axis is showing up. So now what it's going to do is it's actually going to match up the axis of the square dowel with the axis of this hole. I'm going to go ahead and apply this and go ahead and cancel. All right, when I do that, now I can see that we can take this this axle, okay, and it's going to be able to rotate on that axis, and it's going to be able to slide back and forth through it. All right, so that's great. All right, we're in the right place here. What we're going to be doing next is I'm going to come out here now, and I'm going to place, okay, the shaft collar that I created earlier. Okay, and I'm going to drop that right in here on both sides of our Automata box. All right, so now what I'm going to do is I'm going to go ahead and I'm going to constrain, okay, and use mate to attach this face, okay, to one of the sides here. Hit apply, and I'm going to go ahead and flush this, okay, making those 2 faces coplanar. And now in order to finish this up, I can go out here and do a mate between this face, okay, and I can flip this around, okay, to this face as a mate. I'm going to go ahead and hit apply and cancel out. Okay, once we have done that, okay, we're going to see that there is now a relationship, okay, between that shaft collar and that actual axle. All right, now since I built in the distance to my axle earlier, okay, all I have to do is, okay, is come over here. I can pull this down if I need to. That's what everybody always kind of forgets. You can always pull this out, okay, where you can see this. Now we can go into constrain and do a mate between this face, okay, and say we want to mate to that face. We can go ahead and hit apply. All right, so if we've done this correctly, we should have enough of this axle hanging over the edge over here where we can now attach this shaft collar. So we can go to constrain. Okay, I can say, hey, I want this face to mate up with this face. I'm going to go ahead and hit apply. All right, even if it's looking a little bit wonky, it's okay. What we can do is go here to flush, We can pick on this face and say I want to be coplanar with this face, hit apply. All right, and now we're going to see if this guy is able to move. If we need to pull this out to view this a little bit more, okay, now all we have to do is go to constrain and say I would like for this face to mate up with this face. Okay, when we do that, now we're going to see that those shaft collars, which are made of the corrugated plastic, okay, are keeping that axle exactly where it needs to be. All right, so we can see it's able to spin, but is not able to roll along that axis, and that's exactly what we're looking for. Okay, so the next part of this is I want our follow rods to go into the holes. All right, thing is the follow rods are going to be able to move up and down because eventually there's going to be a little pad on the bottom of these that's going to be making contact with the surface of the cams. All right, so in order to do this, all we have to do is go to constrain. We're going to go to the mate type of constraint and the mate solution, and we're going to come in, just zoom right in here, get close to this follow rod. I can see that there's an axis there, so I'm going to go ahead and pick on it to verify that, get close into the hole, get to the inside of the hole, and now we can say, well, I want there to be a connection between those two axes. So I'm going to go ahead and hit apply, okay, cancel out on this, and let's just see what happens. So we're going to see that that follow rod is able to move up and down through that hole. Okay, and if we have done this correctly, that should be directly dead center, okay, with this axle that is here. So we are moving right along. We're going to continue the same thing over here, go to constrain, we're going to go to mate type, mate solution, come in here, find our axis, okay, and meet that up with the axis that's the dead center of this hole. We hit apply and cancel out, and that is going to behave the exact same way that the other one did. Okay, so at this point in time, okay, you are going to need cams. All right, so up until this point, we have not talked about how to create cams with parametric constraints and parametric equations. So at this point in time, if you would like, what you're going to see under the session 2 tab of our website is that you have some cams to use for this assembly. All right, so depending on what story you're trying to tell on top of the automata, all right, is going to depend on the cam that you're looking to use. All right, they're going to give you different motions according to the motion graph established for that cam. So in this case, I'm going to come out here and go to place, and I'm going to pull in the cams I'm wanting to use. All right. So if you do not have these, once again, okay, go down to the second session on our website. You can download those and you can use those. All right, so I'm going to say in this case, hey, I'd like to use the pair. Okay, I'm going to go ahead and drop that in. And I'm going to come out here and place in, I don't know, snails. Nah, I'm going to go with the eccentric. Eccentric is always fun. So let's go ahead and drop in the eccentric. All right, so you're going to see there are a couple things that are happening here. All right, we have a work plane that's going to be bisecting, going directly through the center of that cam, and we can see that there is a square arbor that matches the same dimensions as our square axle, our square dowel, which is a, 0.25 by 0.25. All right, so with that being said and done, what I'm going to do is go ahead and I'm going to probably manipulate this, the rotation of this using free rotate. And I'm going to just sort of nudge this into the right direction, keeping on the inside to use free orbit, getting to the outside to use constrained orbit, okay, and I can get that place kind of where I need it to be. Same thing for pair cam. I can go out to free rotate, stay with inside the globe to use free orbit, use the outside to get this for constrained orbit. So now I have this sort of nudge in the right direction and orientation I'd like to use in order to constrain these. Okay, so with the next part, all right, what we're going to have to do is go ahead and constrain the cams to the axle. So in order to do that, we're going to go to constrain. Okay, now I'm going to come in here and I'm going to say, hey, I want this to be a mate constraint between this face. Okay, and I can say, I don't know, we'll just say that face. I can go ahead and hit apply and go ahead and cancel out. You're going to see that this is able to still shift and move, so I can go ahead and orbit this where I can see that bottom of that face of the cam, and I can say constrain. I would like for this to be mated with the top of this face. I can now go ahead and hit apply. All right, so right now this thing is able to slide, okay, down the axle. Okay, when in reality what we're going to be doing is if we were looking at this from this face, is we want this face here to be dead center, okay, with the actual follow rod here on top. All right, so here's a really cool little solution to that. All right, is if we come out here and double click, okay, on the follow rod, okay, we can talk to this IPT. All right. Now, when we go out to create our first sketch within an IPT, it's going to give us those 3 work planes. All right. And then after you pick a work plane, they disappear and everybody thinks that they are gone forever. Okay. The case is actually they do not. They just simply turn off. So check this out. All right. If I come here to the follower rod IPT within the model, okay, if I come down here to the origin, I can now come out here and find those planes, okay, that I originally had seen when I first created this. All right. What I'm going to be looking for is either this plane or this plane to use. All right, so what I want that to do is to actually stay there. So I'm going to right click on that, okay, come out here to visibility and check it, and now you can see that work plane stays on. All right, at this point in time, I'm still just simply looking at the IPT. I'm still talking to the IPT, so what I need to do in order to interact with the assembly is go out here and hit the return button to come back to the assembly. All right, so now what we have is we have 2 work planes, okay. They're right there, very close together. What I'm going to do is go out here and do a constraint to keep these work planes together, and now that's going to form a relationship where they're going to be dead center on top of one another, okay, in order to be able to work together here in just a couple minutes. All right, so in order to do this, I'm going to come out here, and I can either use mate or flush. It does not matter, okay. I'm going to say I want this face, or this work plane to mate with this work plane. I'm going to go ahead and hit apply and cancel out. And now when I come back here to the cam, I'm not able to move this down the axle like I was a minute ago. Now when I'm also doing that, I'm now locking this this follow rod, okay, where it is going to be dead center, okay, with the top of that cam. All right, and I want that to happen. All right, so we're going to go ahead and do the same exact thing we did before, okay, with our pair cam. All right, this time I'm going to go out here and do a constraint. And I'm going to mate that face there, okay, with one of these square faces here. I'm going to go ahead and do an apply. Okay, I can come into this pair. I can drag this off where it needs to be. Okay, so I can come and find a face in which I can mate that, okay, to the bottom, okay, of the axle. I can go ahead now and hit apply. All right, so we can see that this work plane is going dead center down the center of the cam. All right, and since I applied that work plane earlier to this follow rod, since this is a duplicate, we now see that we have this work plane to work with. And now all we have to do is go out here and do a constraint. It's going to be a mate type of constraint, does not matter on the solution. Okay, so I'm going to go ahead and pick on this work plane and go ahead and pick it to this work plane. I'm going to go ahead and hit apply and cancel out. And when I look at it from this face, I can see that that cam, okay, and that follow rod are directly dead center. Okay, the cam is not able to move, okay, down the axle, all right, and I can see that the follow rod is still able to move up and down. All right, so in reality, all right, we have made these cams out of corrugated plastic, all right, and we've got this very small 1/8 of an inch, well, it's less than 1/8 of an inch diameter follow rod that's going to be making contact with the top of it. What I'd recommend that you do is go out there with corrugated plastic and make some sort of a base or a foot, okay, that's going to be larger than the diameter of that follow rod. It's going to be making contact with the top of the cam. All right, so we're going to go out there and just create that quickly. All right, so I'm going to come out here, create a new IPT. Okay, I'm going to start a 2D sketch. I'm going to come out here and we're just going to make a very simple disc. Okay, and I don't know, let's just make it a 1/2 inch diameter maybe. Okay, finish that sketch. Go ahead and extrude this to the thickness of our corrugated plastic, which is 0.125. And I'm going to come up here and just create this out of ABS plastic because obviously corrugated plastic is not going to be available. I can now go ahead and save that. Okay, and I'll just piggyback off one of these and we'll call this one follower rod base. Okay, now we have that part to use, so I'm done creating that. I can go ahead and close it, and now I can come out here and place in that follower rod base. So I'm going to need 2 of those. Okay, so right now just picture this as the corrugated plastic you're actually going to use with the physical construction of your automata. So what we have to do is go ahead and get this to line up with this and be attached to it. So we can go out here to constrain. All right, the first thing I'm going to do is say, hey, I would like for this face to be making contact with the bottom of that follower rod. So I'm going to go ahead and pick on that face. Go ahead and hit apply. Now the problem is that this thing is going to be making contact with it, but it's going to be able to slide wherever. All right, so in order to finish this up, I'm going to go out to constrain, Okay, I'm going to go ahead and just get to the side of this follow rod base, find the axis, and now come here to the follow rod itself, find the axis. Okay, and it's going to be making that relationship between those two. And something tells me I think I might have moved off of it. Let me just take a look at what happened here. I don't think anything happened. Let's try it again. Constrain, mate that axis to that axis. There we go. Hit apply and cancel out. And now we're going to see that that thing is able to follow the follow rod. It's the very bottom of it. Okay, so we're going to repeat the same process. Go to constrain. We're going to mate that face with the bottom of the follow rod. Hit apply, and now we're going to come to the side of this follow rod base, find the axis, and have that made up with the axis of the follow rod, and hit apply. Okay, now when we move this up and down, we're going to be seeing that that is following it. Okay, last part of this is now we need to create what we call a transitional constraint, okay, between the cam and the actual follow rod base. All right. Remember, everything so far is we're just simply going out and using materials that come with the box kit, okay, according to the sizes of those materials. All right, so let's come up here, go to constrain. All right, this time we're not going to be looking at an assembly constraint. Instead, what we're going to do is come over here and go to a transitional constraint. Here's what I have learned. All right, when you go to use transitional constraints, it is best to tell you just to come here to the bottom of the follow rod base first, and we'll select that face. Now we will flip this over. Okay, come over here to the surface of the cam, and we're going to select that. Okay, now we're going to see that there is a connection between those two. And if we come over here to our shaft collar and we rotate this, okay, we should be seeing that there is, okay, that connection, okay, between the follow rod and the actual cam. Okay. All right, let's keep going here. All right, we're going to come here to the bottom. Okay, go to constrain, transitional constraint again, come to the bottom of this follow rod base and go to the actual surface, okay, of the paracam. Go ahead and hit apply. All right, and that should go out there and give you that transitional constraint. I can see it is getting a little bit fussy. All right, so unfortunately, all right, Inventor can't crunch the numbers sometimes when it comes to transitional constraint. So sometimes what you have to do is go out there and modify the base of your follow rod, all right, and give it sort of a rounded surface. All right, and usually when that happens, what we can do is get this transitional constraint to work. So I'm going to pause just for a quick moment. All right, and I'm going to go out there and actually add something to the bottom of these follow rod bases. Okay, sorry about that pause. I got a little bit ahead of myself. All right, so in reality, what we're going to be doing is creating these flat discs that are going to be at the bottom of the follow rods, and we're calling those the follow rod base. All right, but when it comes to Inventor, it's a little bit fussy when it comes to that transitional constraint. All right, and you just saw that just a second ago. So here was my solution to it. All right, and I have to kind of tell you this when it comes to the Inventor portion. All right, I'm actually going to come out here and I'm going to open that follow rod base, and I'm going to explain to you what I did. All right, so this looks all sorts of ugly because we have work planes on. All right, at the actual bottom of it, what I did was I came out here, all right, and I created this sketch right here. All right, all I did was I just went out there and just put an arc, okay, a nice, large radius arc, okay, and I drew a line to connect that arc together. And then when I went out there, I went to go do an extrude, but when I went to do my extrude, okay, I did a symmetrical extrusion. So if you just kind of take a look here, you can see how it is going to both sides, the distance I went out there and created it as, okay, and I just created this extrusion. All right, so now we have this rounded feature at the bottom of the disc, all right, when in reality, the flat disc is going to work just great, but when it comes to transitional constraint in Inventor, I have learned that you do need to put that little arc at the bottom that's extruded out. Okay, so I'm going to go ahead and just close out of this. No, I don't want to save those changes. I want to keep it right where it's at. Okay, and now I'm going to show you how, once again, we can do that transitional constraint. All right, it can get a little fussy, and this can be a frustrating experience, but if you do put that little arc there on the bottom, it should work. Okay, Just warning you with the word should. Okay, all right, so I'm going to come out here and I'm going to find that transitional constraint. I'm going to delete it real quick just to show you that this will work. I'm going to come out here to the pair, find that transitional constraint, delete it. Okay, I'm going to go ahead and pull these up. All right, let's do this again. Let's do it one more time. I'm going to go to constraint, go to transitional constraint. I'm going to come in here and I'm going to grab that curved edge, that face of that curved edge, and create this face and go ahead and hit apply, cancel out. And now I'm going to come over here, go to constraint, go to transitional constraint, pick that curved face, and now go ahead and pick the face of the pair. Go ahead and hit apply. I'm going to cancel out of that. All right, and now if we come over here to our shaft collar and we move this, okay, we should be seeing that relationship between the follow rod base, okay, and the actual cam. All right, so there you go. Just a little hiccup at the end. Just know when you come to virtual construction of this, okay, on the follow rod base, you do have to give that curved surface, okay, for the transitional constraint to work. All right, so this is the point now when you can go out there and begin focusing on what you're going to be putting on top of those sticks. The top of the follow rods to animate your little scene. So this is when the sort of customization comes into it. Kids can get very, very creative, creating their own little parts, maybe some sort of linkage between them. But this is very basic assembly and construction of the Automata using the PLTW box kit.